Okay, some more of section 9.1. This is number 11. And on these problems, they say tell whether the series converges or diverges. If it converges, give its sum. So if I looked at the first series, I didn't write it down, but if you look in your book, it's 1 plus 2/3 plus 2/3 squared plus 2/3 to the third. So it looks like we keep just multiplying by 2/3. So it looks like my a sub 1 is 1, and my ratio is 2/3. If I multiply 1 by 2/3, I get 2/3. If I multiply by 2/3, I get 2/3 squared, 2/3 third, etc. So I've got a geometric series. My ratio, my r is less, the absolute value of that is less than 1, so it definitely converges. So geometric series, ratio 2/3. So I know the sum is equal to a sub 1 over 1 minus, and I gave you that formula on the last, remember, the sum equals a sub 1 over 1 minus r. Very important formula. And again, remember the absolute value of r, it's got to be less than 1, and that's the case. So my a sub 1 is 1, and my r is 2/3, so it's 1 over 1 minus 2/3. 1 minus 2/3 is 1/3. 1 over 1/3 is 3. So it converges, and that's the sum. On number 12, if you look at number 12, it's an alternating series, so the nth term, and they actually give you the nth term, and if you take the limit as n approaches infinity, that actually goes to infinity. But it oscillates also, so since a sub n does not approach 0 as n approaches infinity, it diverges, and that's from that little theorem we talked about. You can tell if there's easy ways to tell whether a series diverges by looking at that nth term. All right? If the limit is 0, that doesn't necessarily mean that it converges, but if it's not 0, you know it diverges. So, okay, and then number 13, if I look at that series, it's a summation. N goes to 0, so you can write out some terms. If you wrote out a few terms, you would see that when n is 0, you've got 5/4. When n is 1, you've got 5/4 times 2/3. When n is 2, you've got 5/4 times 2/3 squared. So it looks like your common ratio is 2/3. So I used a sub 1. Excuse me, that's not. That should be a sub 1, not a sub n. Pardon me. A sub 1 is 5/4. That's my first term. When n is 0, you see you have, if you look at your series there in your book, 2/3 of the 0 is 1, so you have 5/4, so that's your first term. And then you just keep multiplying by 2/3, so that's your common ratio. So again, we have the same ratio, 2/3, just a different first term. So it is a geometric series because the absolute value of r is less than 1. And I can actually find the sum, and that's going to be my a sub 1 divided by 1 minus r. This formula here. And 1 minus r is 1/3, so I got 5/4 divided by 1/3, or times 3 over 1, and 15/4 is my sum, so it does converge. And then number 14, that's another geometric series. That's nice, isn't it? Except, what's the ratio? Well, my a sub 1 is 2/3. You can put 0 in there, and you'll get 2/3, and then you start multiplying by 5/4, which is your common ratio, but that is greater than 1, so it diverges. It's a geometric series, but it diverges because the ratio is greater than 1. Okay? So those weren't bad. After the first two, those aren't bad. Okay? 1 and 2 are long, but 2 through 14 were a little bit easier. Okay? Hope those help.